All right, so the first limit I'm going to do now is the limit as x approaches infinity of sine of 4x. So in this case, I'm going to rely on the graph of y equals sine of x. The graph of y equals sine of 4x will be similar. It's going to have that same shape that we're familiar with for the graph of y equals sine of x. The 4 does change the period, so it's going to condense the period into 2 pi divided by 4, so pi over 2. That's not really critical to the big picture here, which is, okay, so graph looks basically like this. Oscillates between -1, or the values between -1 and 1. It's going up and down between those values. So as x approaches infinity, sine of x and cosine of x for that matter, or sine of 4x, we're just going further and further down this graph. It's not approaching any single value. It's just going back and forth, back and forth, back and forth. And so we would say that this limit does not exist due to oscillating behavior. Okay, so that limit doesn't exist. Example B here. So the limit as x approaches negative infinity of 2 times cosine of 3 over x. Well, so there's a property of limits that says we're allowed to take the limit of just the inner function. When you have like a f of g of x situation, so you have one function inside of the other function, it's okay to think of this as 2 times cosine of the limit as x approaches negative infinity of 3 over x. That is a limit of the form finite number over negative infinity. So when you have a finite numerator and the denominator is just increasing, or in this case decreasing without bound, I'm looking for my red marker, then this 3 over x is approaching 0. So as x approaches negative infinity, the argument, what's inside of that cosine function, approaches 0. And so the limit here is equal to 2 times cosine of 0. Cosine of 0 is 1, so this is 2 times 1, and our limit is 2. So in this case, the limit exists because as x approaches negative infinity, we end up just taking cosine of 0, which is a finite number. Whereas here, the argument, what's inside of the trig function, is just, it's going to infinity, which as what's inside of the sine function approaches infinity, sine's just going up and down and up and down. Same deal for cosine. It's not approaching any fixed value, and so the limit does not exist.